Ma'am, we'll start the program. Yeah, student coordinators, please proceed with the proceedings.
Yes, sir.
Yeah.
Yes, sir. Honorable dignitaries, eminent speakers, fellow students, and beloved audience. Once again, welcome back to the day 2 of Second International Conference on Sustainable Construction Technologies and Advancements in Civil Engineering, being organized by the Department of Civil Engineering, SVCW, in association with Indian Concrete Institute, a student chapter. Day 1 of ScTACE 2021 witnessed a charming flow with keynotes from eminent speakers and noteworthy presentations by the authors.
With more grace, let us begin the second day of our conference ScTACE 2021 with a keynote entitled A Comprehensive Outline of the Necessity for Sustainability in Engineering by Professor S. Jayalakshmi Garu. Professor S. Jayalakshmi has received her bachelor's degree in civil engineering from Government College of Engineering, Tirunelveli in 1990, master's in geotechnical engineering from Annamala University in 1995, and PhD in geotechnical engineering from IIT Madras in 2004. She is in association with NIT Tirchi for over 21 years and is working as a professor to date. Professor Jayalakshmi was honored with Bharat Jyoti Award by the India International Friendship Society, New Delhi in 2008, and venerated with International Geosynthetic Society Student Award from the International Geosynthetic Society in 2004. In addition, she was felicitated with the Thiru Meenakshi Sundaram Pillai Merit Prize for securing university first rank in Masters from Annamala University. Furthermore, Professor Jayalakshmi earned notable certificates for guiding the team from NIT Tirchi at ICI IITM National Concrete Canoe Competition for significant contribution in annual technical volume of Civil Engineering Division Board of the Institution of Engineers on traditional irrigation systems in India and many more. Professor Jayalakshmi represented the NIT Tirchi in the ISRO Respond Exploratory Meeting at VIT Vellore in 2016. She also acknowledged a collaborative project with Ms. Golcha Associatives, India's largest talc manufacturer. She was positioned in the organizing committee of ACE 2016 International Conference, Singapore, and served as the track co-chair for civil engineering in FEAST 2017 and 2018. In addition, she was reviewed for Institution of Engineers and the Canadian Journal of Geotechnical Engineering. Professor Jayalakshmi is a life member of the Indian Geotechnical Society, Indian Geotechnical Society Chennai chapter, Indian Society for Technical Education, and a member of the Institution of Engineers. Professor Jayalakshmi has guided over 50 MTech dissertations and 3 PhD students. She has authored and co-authored numerous national and international publications and has been a prominent speaker in several events. Professor Jayalakshmi's research interests reside with geosynthetics, lunar simultaneous, environmental geotechnique. With this brief intro, I would like to call upon Professor Jayalakshmi to proceed further with her talk.
Thank you. Good morning and happy Dasara to every one of you who are here, eagerly present here to hear my talks. I am very much glad for the introduction and also for getting an opportunity to present what are my views about sustainability in this conference. And I should say that I am a pygmy amongst giants here, but still some of my points might be worth noting. Because as Thiruvalluvar says, like even if we have a small spoke, that spoke is important for moving the wheel. So in that context, I would like my address to be taken. So if there are any mistakes, you just point it out to me. Thank you very much. And I will share the screen now.
Yes, ma'am.
Thank you. So today's talk is going to feature a comprehensive outline of the necessity for sustainability in engineering. So far you might have heard very much about sustainability, but I am giving a few points, very few points, which is giving the importance of necessity of sustainability in engineering. And the contents, it will be like this. First, I will deal with what is sustainability, then what is the origin or need for sustainability, sustainability in the society, sustainability in engineering, and sustainability in civil engineering context, especially in structural engineering field. Okay, so then I would also be giving sustainability as seen from the eyes of the presenter, that is myself. Okay, and let me go into what is sustainability as defined. So we have the sustainability development goals or global goals, and if you look at my picture, you can find that we are finding some parrot there, and we are finding a fish there, we are finding a tiger there, and we have the humans here. So we, the human at the end of the chain, we are deciding what is happening in our planet. And these planet, it should be safe against exploitation. So we have to have some goals for that. And that is what United Nations in 2015 tried to make by giving the Sustainable Development Goals or global goals. And it involves an universal call to action to end poverty and protect the planet. And what is the need for this, or what is the motto behind this? It should ensure by 2030, we are already in 2021. So to ensure by 2030, all people enjoy peace and prosperity. So ultimately, human mind wants to be happy, and this is what we need. So for that, we have to be sustainable. That is what is the key theme of the talk here. So if you look at the 17 goals, we have no poverty. Like poverty is the main reason that we are having this unsustainable conditions. So if we eliminate poverty, everything is good enough. And if you need to eliminate poverty, the first requirement is agriculture, is it not? So we will be seeing something about how women and men together, they participate in the agricultural activities of our country also. So now we should have a condition where there is zero hunger. And the third goal is to have good health and well-being. Then we should also have quality education. If we are as a society to exist and coexist together, we should have quality education. And that education should ensure gender equality. It should not be having gender inequality. It should be assuring gender equality. And we should also have something to drink properly, that is clean water and sanitation facilities. The seventh item on the list, it is affordable and clean energy. So nowadays we are talking about energy audit and so on, but the concept is there for a long time. For example, we actually celebrate Shankranti, right? What is the principle behind that? We value the energy which is given by the solar sun. Okay, so like that, affordable and clean energy we have to have, and decent work and economic growth, and industry, innovation and infrastructure. So unless we have enough infrastructure, we cannot house our societies. So we need good infrastructure, and in the process, we should also see to it that there are reduced inequalities. And the cities and communities which develop are sustainable. And when they are consuming, they consume responsibly. For example, if we are actually holding festivals, we should see that a lot of food should not be wasted. Like what is enough, we should make and we should enjoy that. Okay, and climate action, we should also look at our planet as a whole globally, and climatic actions which influence global warming, etc., should be avoided. And life below water, for example, in the sea, we have trawling action of the fish during off breeding seasons. So that will actually eliminate the fish. If the fish is out of the cycle, then everything is out of the cycle, right? So even one living being, if it goes out of the life cycle, then everything is lost. So it affects the human being indirectly. And life on land also, we exist and coexist with the wild and domestic animals and plants, and also the birds and other insects. Okay, so each life is important for us. So we should think about that before destroying the links in the ecosystem. And ultimately, like, we should also have peace, justice, and strong institutions, and we should have partnerships for the goals. So my topic, which I am going to outline here, is actually giving some insights into how the dynamics of work environment will be there. And if you look at the side, the goal 1, 2, and 3 and 6 are interlinked. Goal 2, goal 4 and 5 are interlinked. Goal 11, 12, and 13 are interlinked. So if we are upsetting one goal, and if you are not fulfilling one goal, it means that we are not able to fulfill the other goals. Of all the skills that is necessary today, what we need is ICT skill. Okay, we have information and communication technology skills. And if you look at India, we find that our basic youth and adults have this skill a lot. And the average IT budget is 31% of personal costs, 29% of software costs, and 26% of hardware costs, and 14% of costs of external service providers. And the estimated money to be spent on this is US $6 trillion. So we should actually pay very much importance to this IT sector also, where we can have sustainability. Okay, the costs of external service providers, if possible, should be reduced. And if we look at what is the proportion of women in parliaments and local governments, we find that in Oceania, it is okay. In terms of local government, we are sharing the seats, but in case of parliaments and other governing bodies, the representation of women is still less over the world. So it is necessary that women participate in governing actions of the world councils. Okay, so as a women college, I would like to highlight that you are not very much less in quality or quantity than any other person. So you should strive to come out as an individual and thrive and shine and take up responsibilities in every field. And that includes agriculture also. So if we want to eliminate poverty, we should have more of women participating in agriculture. But if you look at the percentage of women who are occupied in the agricultural activities, you find that only 6.3% of women are actually involved in securing rights and ownership for agricultural land. And if you look at the men, it is 39.8%. So compared to that, we are at a disadvantage. So it should be ensured that there is a equality in this section. And if you look at what are the interlinking factors, we find that this society, economy, and environment are interlinked. And how we can do that? We should offer individuals and communities the opportunities to increase their capabilities. So they should know their needs and wants, put primarily focus on achieving needs of larger number of individuals, allocate in a fair manner benefits and costs related to economic activity and public policies. So here comes the public policies, in which case we should ensure that women also have ownership of the land, and we should maintain a positive, genuine long-term investment considering all types of capital. So women should participate in every activity and stimulate. Am I audible?
Ma'am, please, sorry, ma'am, please continue, ma'am. I'm taking care of it.
Okay, right. What we should have, we should also ensure that all material and energy inputs and outputs are inherently safe and benign as possible. And we should look beyond our own locality and immediate future. Like, we should not be, in simple words, we should not be selfish. Like, we should think about what our future generations need, and we should plan for that. And when we participate in some activity, we should take the opinion of every stakeholder involved, and we should also internalize the cost within the values of goods and services which we are providing. For example, e-waste is a very big problem nowadays, and if we have this polluters, we should have a concept that polluters must pay. And this is not the thing. We just dump the waste now, even though we have environmental regulations. And the engineering processes holistically using system analysis and integrate environmental impact assessment tool. For example, we have a project, we should have an impact assessment of that on the environment also. And we should preserve access to ecosystems, services which are essential for the health and well-being of the society. And we should also develop a closed cycle which minimizes waste. And I will be emphasizing on this again and again. And once more, we should see to it that we preserve biodiversity and respect all life forms, regardless of how useful they are to mankind. We cannot ignore a single individual, or we cannot ignore a single life form, because it is not, because what we think as useless might be useful in the whole of the system for the universe. So stay within the ecosystem's carrying capacity in terms of resource development and waste assimilation. So this I have drawn in a concept from Sunderstein Conference of 2003 on Sustainable Development in Engineering. And what are the origins or need for susceptibility? So before that, I would like to draw your attention to some questions. What is sustainability? Why do we need to practice sustainability? What are sustainable practices in engineering, and sustainability in practice at global level, and sustainability in civil engineering? So sustainability is the desire to perform activities without depletion of the resources and without any harmful effect on the environment. And why needed? We should practice sustainable construction. As civil engineers, we should be able to provide a sustainable construction. For example, we have bubble decks here, like where we put plastics inside the beams and we cast them. And we have bubbled RC slabs. We have a lot of bonded strength and deflection RC beams, bubbled RC beams. We have precast construction nowadays, so to increase the pace of the construction. So all these should be achieved. And when we are achieving that, we should see that as much green concepts as possible are actually a part of this. And sustainability is the capacity to endure. It is able to sustain for a long time. Long-lived and healthy wetlands and forests are examples of sustainable biological systems. And for us, even though we know much about this chemical cycles, invisible chemical cycles which are existing redistribute water, oxygen, nitrogen and carbon through the world's living and non-living systems and have sustained life since the beginning of time. So the three principles of sustainability are See, we should look at the society, we should look at the economy, we should look at the environment. And if the environment and the economy are taken into consideration, then it might be viable. And if you take the society also into account, then it is sustainable. Okay, these are the principles, and informally they are profit, people and planet. We can tell in these words also. And if we look at the definition of sustainability of Paul Hawken, sustainability is about stabilizing the currently disruptive relationship between Earth's two most complex systems. What are the most two complex systems? It is human culture and living world, the way we live and the world which exists with all its life forms. And from there, I would jump to Laurie Baker. He is no more here, but he was a great soul whom I would like to recall. And today is Dr. Abdul Kalam's birthday also. So I just wanted to remind of a great event of Laurie Baker's happenings. Once, he was famous for cost-effective, energy-efficient architecture and designs that maximize space, ventilation and light, and maintained uncluttered aesthetic sensibility in construction. So Baker was asked by Mahatma Gandhi once, like, what do you think as the best house? But Baker could not answer this, even though he is a great person. He was not able to answer this. Then Gandhiji gave him the answer, which house does not require any transportation for construction is the best house. Okay, so just think about this. Think local but act global. This is what is the phenomena behind this. So if we can get material nearby, why go somewhere else to procure that? That was the concept Mahatma Gandhi was advocating. And influenced by Mahatma Gandhi and his own experience, what Laurie Baker did was he considered regional building practices and used local materials which were sustainable. And even if he had to cut a tree, he had to think hundreds of times, and generally he desisted from cutting the trees. And if he is asked, like, what is the shape of your house? Baker used to say, there is a tree here, there is one there and a third one there. I do not want to cut any trees. And around the trees, he used to build the house, and the tree trunks used to be inside the house. So like nowadays, we don't think that much. We just put concrete blocks. So we have to put some sustainable things also. And he also provided cooling systems. And how did he provide the cooling system? He placed it near a high lattice brick wall near a pond that uses air pressure differences to draw cool air through the building. And he was using recycled material. He had natural environmental control and frugality of design. So I should say that frugality of design is very important. And what are the forms of sustainability or living takes? Like reorganization of living conditions. So we should not think like big is good. Even minimal things are good. So we should develop eco villages, eco municipalities and sustainable cities, and reappraising economic sectors, permaculture, green building and sustainable agriculture. Or we should have work practices which have sustainable architecture. And we should use green technologies or renewable energy to adjust in lifestyle and individual lifestyle that actually conserves the environment. And the three pillars of sustainability, they are not mutually exclusive, but can be mutually reinforcing. That is what this gives here. And if you look at the principles and concepts behind that, the consumption is in the population, technology and the resources. So if the human impact was developed in the 70s, so we as humans are the ones who are affecting the environment. So it was given by the relationship that is I equal to P into A into T, where I is the environmental impact, P is the population, A is the affluence, okay, and T is the technology. So if you have the technology, if number of people are using it, you will find that the environmental impact is more. And if you look at how to measure sustainability, the sustainability is still evolving as a branch, and it's applied over a large temporal and spatial scales. And we also measure in terms of corporate sustainability reporting. Nowadays, corporates have social responsibility also as a carry a tag with them. Like how sincere it is implemented, that is more important, okay, for sustainability. And we have triple bottom line accounting and estimates of sustainable governance for individual countries using the environmental sustainability index. And we also have another index, which is the environmental performance index. And we should look at these things: the population, the carrying capacity of the globe, the global impact on biodiversity, environmental dimension, environmental management, management of human consumption of resources. The environmental management consists of managing the atmosphere, which we should eliminate greenhouse gases as much as possible. And also fresh water and ocean should be taken care of. Land use patterns should be registered, and loss of biodiversity should be prevented. So if you look at this picture, you can see that we have hydrogen fuel cells, and we can also have carbon stored in the plants and soils and microbes. So it's a chain here. And ultimately, what is the use which we are putting it to? We are putting it in the industry, and we are providing emissions. This emission again goes back, and we have carbon uptake by the plants. So ultimately, we have to preserve our life forms. So that is what is more important when it comes to sustainability. So water security and food security should be there, and toxic substances should be off the ecosystems and are mitigated from the ecosystems, and waste recycling should be the order of the day. If you look at the waste hierarchy, what is the most favored option and what is the least favored option? That has to be. So we should prevention is the most favored option, and distance is the least favored option, whereas minimization, reuse, recycling and energy recovery are the other options. So we have economic dimension, in which case decoupling environmental degradation and economic growth is very, very important. So in the social dimension, we should have peace, security and social justice, minimizing resource wars and human settlements. And the ways in which sustainability principles can be given: we should have less dependence on fossil fuels, underground metals and minerals, and we should also reduce the dependence upon synthetic chemicals and other unnatural substances. We should reduce encroachment upon nature, and we should meet human needs fairly and efficiently. So at that point, I would like to draw your attention to the human factor, and human factor is what actually decides the work environment. So in the work environment, we should be very, very vibrant. So we have the set of economic and environmental and social conditions, and we have policy statement 418 of the ASCE, which says that the role of the civil engineer is to follow the triple bottom line, in which all of society has the capacity and opportunity to maintain and improve its quality of life indefinitely without degrading the quantity, quality or the availability of economic, environmental and social resources. Sustainable development is the application of these resources to enhance safety, welfare and quality of life for all of the society. So now, I have my own visions of sustainability as I see it. The first point that has to be noted is live and let live. And second point that has to be noted is it is not conceptual but to be implemented in practice. and live and let live needs tolerance and full compliance in terms of ethical standards. Since the resources, that is human resources and fossil resources, are exhaustible, fully optimized use is necessary. For that, conducive environment is a must, and this holds good in the work environment too. Human interactions or human factor is something that cannot be ignored in shaping society, economy, and environment. So if a nation or a world is to be sustainable, each human entity should perform optimally with minimalistic, simple lifestyles, giving maximum production. This is only possible if we have ethical orientation, gender equality, and good education. So do the right project and do the project right. This should be the principle 1 and 2 on which we should operate. So ethical standards should be adhered to. So with this note, I would like to draw my attention to the sustainable versus traditional engineering practices. Like we integrate technical and non-technical issues, but in traditional engineering, we focus on technical issues only. And in sustainable engineering, we make sincere effort to solve the problem for the indefinite future. Whereas in traditional engineering, we solve the immediate problem. And in the global context, we are considering sustainability, whereas in the local context, we are considering traditional engineering. And the traditional engineering design criteria is function, cost, and safety, whereas the sustainable engineering design criteria is safety, function, cost, impact on the planet, and impact on the society. So these are my references, and thank you for your patient hearing. Thank you very much. I hope I have been on time.
You are on time, ma'am. Thank you very much, ma'am, for giving a very nice outline of the necessity of this sustainability in engineering. And hopefully the participants all got some information. Thank you very much for your acceptance and presenting this informative session to us. Thank you very much, ma'am.
Thank you. Thank you.
Yeah.
So I can leave?
Yeah, yes, ma'am. Please. We will continue with the next slot. Thank you, ma'am. Yeah.
Thank you.
Yeah, coordinators, please proceed with the next slot. Pujita? Hello?
Yes, sir.
What happened?
Thank you, ma'am, for taking out time from your busy schedule to provide us with such a valuable information. Also, we would like to convey our heartfelt wishes to you for being such a wonderful guide for Dr. Pala Girish Kumar sir during his PhD. It's your it's for your guidance. We have got such a splendid person as our head of the department. Once again, thank you, ma'am. Now, let us move forward with our next keynote on data mining and decision making techniques in water resources engineering by Professor K. Srinivas Raju garu. Professor K. Srinivas Raju has obtained his BE in Civil Engineering from Acharya Nagarjuna University in 1987, Masters in Water Resources Engineering from IIT Madras in 1991, and PhD in Water Resources Engineering IIT Kharagpur in 1996. He has worked with Professor Lucien Duxton in the field of multi-criterion decision making with reference to water resources planning during his postdoctoral program in France and is currently positioned as professor in BITS Pilani, Hyderabad. Professor Srinivas Raju has been honored with several awards inclusive of Sir Arthur Cotton Memorial Medal by the Institution of Engineers in 2002. S.N. Gupta Memorial Award for Research Contribution to the Field of Water Resources Engineering by the Indian Society for Hydraulics, and Best Paper for the paper I Manager International Conference on Engineering and Technologies in 2015. Best Research Paper Award in International Conference on Water, Environment, Energy and Society, jointly organized by AISECT University, India and Texas A&M University, USA. He also received appreciation as an outstanding reviewer of the Journal of Hydrologic Engineering (ASCE) for the years 2014 and 2016. He served as the member of the International Editorial Board of Journal of Water and Climate Change and associate editor of H2 Open Journal, IWA Publishing. He is currently holding the cadre of editor in Journal of Water and Climate Change, IWA Publishing, and associate editor in ISH Journal of Hydraulic Engineering, Tyler and Francis. Professor Srinivas Raju has published more than 130 papers in various reputed journals and conferences and has been a reviewer for more than 44 international journals. He has co-authored 3 books with Professor D. Nagesh Kumar, and they include Fluid Mechanics, Problem Solving Using MATLAB, published in 2020 by Prentice Hall of India, New Delhi. Impact of Climate Change on Water Resources, published in 2018 by Springer, and Multi-Criterion Analysis in Engineering and Management, published in 2010 by Prentice Hall of India, New Delhi. Professor Srinivas Raju has accomplished 5 sponsored projects, including 2 collaborative projects with IISc Bangalore on climate modeling and integrated urban flood management, and is working on collaborative sponsored project rainfall runoff modeling for lower Godavari basin in a changing climate with IISc Bangalore, sponsored by CSIR. His research interests include impact of climate change on water resources system, multi-criterion decision making, and soft computing applications in water resources engineering. And now I take the privilege to welcome our eminent speaker, Professor K. Srinivas Raju Garu, to proceed with his talk.
Yeah, thank you, Pujita. Morning, Professor Girish. You are able to see my screen?
Yes, sir. I am able to see. We are able to see, sir.
Okay. So my understanding from now, we'll have around 30 minutes. Is it right?
Yes, sir. Yes, 30 minutes.
Yeah, great. So my topic is the data mining and the decision-making techniques in water engineering. In fact, I am not discussing too much mathematics. I will tell briefly the philosophy behind the cluster analysis, which is a main component of data mining. Again, which is mainly useful for useful as the decision-making techniques. And I prefer to discuss 2 case studies, which I hope it will give a lot of idea. So, in fact, this is part of one of CSR project, which is my presentation, and part of the book written by myself and Professor Nagesh on the climate change book, Springer. So my topic was on the classification necessity, the cluster analysis, fuzzy cluster analysis, and coherent neural network validation techniques, and the case studies. So when we say the data mining, what is meaning of data? Some data is there. You are trying to understand, analyze, maybe digging the data for number of purposes. So the number of components of data mining, number of components. In fact, some point of the time, the areas are becoming converging. The data mining, machine learning, artificial intelligence. At some point of time, it becoming a same common thing, which is trying to handle the data much more better way. So my thinking of the data mining today is in terms of mainly the clustering algorithms and some of the case studies. So whenever you say clustering, what is the purpose of clustering? Cluster, classify the data sets. For what? Let us assume what is the purpose of classification? To make the data more manageable number of sets. Why should they worry? Why should they make the data into groups? Because if there are 1,000 data sets are there, analyzing data sets of 1,000 will be very tedious job. And we know most of the time, some of data sets looks very similar. So what is best possible action? Best possible action maybe try to arrange the data in small groups so that instead of handling 1,000 data sets, we will handle only 10-15 representative data sets representing their particular cluster. For example, this is your original points. They made 2 clusters. It is technically 4 clusters, not 2 clusters, 6 clusters. So what is the advantage now? I need to bother this many data points. What I can bother? Out of this 4, 1, out of this 4, 1, 3, 1, out of this 3, 1, out of this 3, 1, like this. That means what? All 4 are almost similar. I never say similar, almost similar. I will pick up which is highly similar. That means that instead of having this many points, I will run my modeling purpose for how many data sets? 6 representative data sets representing all the data available with me. So that is the purpose of simple purpose of clustering, where I am trying to organize the data sets into groups. Groups means people call clusters, classifiers, whatever. But some simple mechanism where we are trying to group the data sets which are similar in nature for number of purposes. You take any data mining, take any purpose. That means that I can spend more time effectively on the limited number of data sets instead of confusing myself and working with thousands of data sets. Then, so their number of algorithms are there. Again, the cluster analysis two situations. One situation is what are data coming to me? I am assuming that data is precise. Precise means what? Accurate. What is the second understanding? What are data coming to me? It is not precise. It is imprecise. Remember, one first understanding, data is precise, and that means everything perfectly fine. Second is what? The data is imprecise. When I'm trying to assume data is precise, I'm using a K-means algorithm, a simple deterministic approach, where the algorithm is very simple. In the case of uncertainty, I will tell you the reasons behind uncertainty, where we'll have some type of a impreciseness, where the K-means will not work out effectively. I have to expand this K-means into a little bit a better version, which I'm calling as the fuzzy C-means. I'm not going too much mathematics, but I prefer to go to discussion case studies where you will enjoy more. So that is about the algorithms. In fact, you take any data mining algorithm, the step, you take either fuzzy C-means or K-means or Cohenon, whatever. There are certain steps are there that most of the time we have to make the data normalize so that the data will be dimensionless. We should run our algorithms with some minimum number of clusters and maximum number of clusters, so that I will have some idea. Okay, this is a tentative representative data clusters which you can think of. This we're calling a sometime a termination criteria. That means when I can stop my clustering algorithm like this. So at some point of the time, my agenda will make sure that the data is clustered such a way that then somebody can ask me, how you know the clustering done effectively? At some point out there are number of indicators are there. One of the indicators is that the error should be minimum. Error should be minimum, and as number of iterations are increasing, error is expected to decrease at some minimum point. This is about the K-means algorithm. Anybody have any challenge? Because I am not able to present complete in 30 minutes. Anybody have challenge? I will be available today evening. Maybe you can check with Professor Girish. My time I can discuss more also. That is about the K-means algorithm. The second algorithm which I can call is about the fuzzy cluster analysis. When I'm using then what is the purpose of K-means cluster analysis, fuzzy cluster analysis? Same, grouping the data sets into homogeneous fashion. Then somebody should ask me, sir, why you are going for fuzzy cluster analysis? Question mark. Because I know the data is uncertain. Naturally, I have to go for a little bit sophisticated techniques. Naturally. So that is the reason we may go for the fuzzy cluster analysis, or people call fuzzy C-means. K-means means mainly for the deterministic, fuzzy C-means mainly for the imprecision handling. So before going to fuzzy C-means briefly, we should know very clearly what is the causes of uncertainty. So one is what? Some information will be there. I cannot quantify the information. For example, somebody say, I don't have data of the rainfall. So somebody will come to me, sir, what is rainfall today? I'll simply rainfall is heavy rainfall. So if when I don't do data, when I'm using something like heavy rainfall, I should use some type of my whatever logistics skill I thought I'm having. I'm trying to use saying that, okay, this may be the rainfall. That means what? Some information I am not getting, or some information I'm getting, but I'm not able to quantify properly. You can ask me, sir, if we could not quantify, shall leave this part? We cannot leave it because we are supposed to modeling at some point of the time. That means it is not possible in our lifetime waiting for some data to run it. That means that we are taking some approximations assumptions to bring some data to some type of a shape, but not complete shape. The second is about incomplete information. Information is there, but it is not complete. Number of times it happens. Then the third thing about what? Non-obtainable information you cannot get at all. That means what I'm supposed to do? I would assume some data. Simple example, you are all civil engineers. At some point you see, for example, a simple example is called infiltration. So sometime infiltration data I am having, sometime I will not have. Most of the time I will not have. In that case, what I will do? I will try to assume some data based on nearby conditions. I will try to bring some commonality. I will try to use that data. So you can see every point of the time I am assuming some information due to number of reasons. So all these things cause of uncertainty, which means the data going to model is uncertain. Naturally, the data coming out of the model is again expected uncertain. There is a confusion about it. Now, if data is precise, you can expect data is expected to be output to be precise. If not, you will have a challenge. So these are situations not only fuzzy crystal analysis, any of the uncertainty modeling, hydrology, structural engineering, transportation engineering works because same philosophy. Data is not available. I have to assume some assumptions to run my model. You cannot simply say, no, sir, I'll wait for data. It will never occur technically. So this is causes of uncertainty. So based on uncertainty, the cause we are using here a fuzzy cluster analysis. Fuzzy cluster analysis is a simple, what I can call a simple tool. But I always regard these techniques because they are very powerful techniques. They create, I will say, a lot of impact. The other category of classification, which I'm calling data mining only, based on the neural networks. So that is this approach is called coherent neural networks. So like this, you are having what I can say, the number of classification algorithms are there, number of classification algorithms. What is the purpose of that? Some data comes to you, the data with 1000 data sets, 2000 data, number may be bigger, number may be smaller, doesn't matter. If somebody can ask me, so if a number is smaller, why should I go for data mining? If a number is smaller also, if given opportunity, I prefer to go for the data mining technique so that instead of handling 20 data sets, I will spend my time with only 4 or 5 data sets. So much comfortable you are. That means you are spending your quality time in your modeling part. So that is very important. Doing hurriedly for sake of doing it, anybody can do. But what you can do best possible, you simply take the data, arrange the data, analyze the data, try to make a form of a groups so that you know very well that instead you need not handle 1000 data, you can handle only 10 reference data sets. Those 10 only can work out. So this is applicable whenever we go for a decision making algorithms. Decision making algorithm is what? Mainly to rank which is the best alternative, best data sets in fact. So that is nothing but that the reason nowadays data and decision making techniques are becoming very, very common at some point of time. For what purpose I'm doing all these things? I'm doing mainly for to take some type of a decision only. So that is the purpose of clustering algorithms. I'm repeating once again, the purpose of clustering algorithms is to classify the data sets and make some reference data sets which I can use it for further. Further means what? Any purpose. Decision making, ranking algorithms, anything. That means I am trying to create a platform so that the data which is clustered can be used for the other purposes. So whatever I told briefly about k-means or fuzzy c-means or Kohanon or electric tree, a lot. Purpose is same, but they work with certain different philosophy. In the k-means and fuzzy c-means works with the same philosophy, but k-means assumption is that whatever data coming to me is very precise, whereas fuzzy c-means data coming to me is imprecise. Typically with the coherent neural networks, again, which will handle again, the data is precise situation only. So that is about the clustering algorithms. The other simple extension is called validation techniques. The point number one is that somebody having 1000 data sets, somebody comes to you, sir, please cluster my data sets. You can do it. That is not a big process. What a process is that how you know out of 1,000 data sets what is the optimum clusters I can make. Some point that is a puzzle to me. Somebody 1,000 data sets I can make 10 clusters. Definitely my neighbor will ask me why 10 sir, why not 50? You know, tricky questions. And the tricky question will have answers in the mathematical context, which this is nothing but a wonderful research area called cluster validity indices. Number of techniques are there which do the job best possible way. So that's the reason clustering is one segment, one research segment. Validation technique is another research segment. So if you combine these two, this is a wonderful research area. You can really think of not only civil engineering, any field of engineering, any field of management. But the purpose is to find out the optimum clusters. Then, so what I'm trying to do, I'm just to show you one case study to start with. Time permits, I'll go to second case study. So the case study which will pick it up is nothing but what? The clustering of GCMs. Everybody is speaking about the climate change these days. GCMs are nothing but a global climatic models, technically a mathematical models which are developed technically at the hemispherical level, main for the purpose of the predicting the future data. Which data? Or I will say the based on the GCM data only we are predicting the future rainfall, temperature, etc. Future means from tomorrow onwards, after 10 minutes onwards. So the GCMs are nothing but a global climatic models. Then somebody should ask me, sir, why should I cluster these global climatic models? Interestingly, what happens here, some of the global climatic models are looks similar, but not similar. Both are different. Similar means what? Exact. Look similar means what? In every GCM, they will have certain components in terms of what? Numerical schemes or parameters, etc. So we try that. So then you can ask me, why should I cluster? Because instead of running, instead of using number of GCMs for a modeling purpose, what I can do, I can pick up group of GCMs so that they will not overlap in my modeling purpose. That is the purpose of the clustering of global climatic models. Global climatic models are nothing but a simple mathematical models. Simple, I will see still more simple term, simple computer programs. You can see here, so this is the model developed by the Beijing Climate Center, China Metrological Administration. So what is this model? This is one of the simple computer program, simple mathematical model, which simulates the future weather information. Like this, you will have the number of organizations. Interestingly, there is another model developed by the same organization. So then you can expect that there may be some similarity in these models. Definitely, it will not be they're different agent, right? There may be small extension will be there. So this is the reason we thought that because at some point in time, any climatic modeling, the global climatic models are the basis. Or I will say this is the one of the what I can say a major supporting structure. Based on GCM, I will downscale, then I will use multiple hydrologic modeling, etc. That means that the root cause of accuracy of your predictions depends on what? Your selection of the GCM. So the number of time people say you should not take one GCM, you should take multiple GCMs. Again, question mark is what is meaning of multiple. And for example, I will take these two GCMs for modeling, but I know very well that there is some commonality will be there. So keeping all these things in view, we thought as part of sponsored project of myself and Professor Nagesh. So we thought we'll explore a typical purpose of a clustering of the global climatic models. We have taken here, there are technically you can see the 36 models. 36 models. That's all. You can see here, interestingly, these three models are developed by the same organization. So different, there may be some commonality will be there. Then you can ask me, sir, you can take any one, sir. How I know which is appropriate for me? I know these are going to be grouping, likely. So keeping all this in view, we thought we'll go for some type of using a data mining technique like a cluster analysis. Then, so again, a summary in the form of a table, nothing else. So here, interesting point, one more is that here, there we have taken here three parameters, or maybe two variables I will call. One is what? Maximum temperature. One is the minimum temperature. We also taken a combination of maximum and minimum temperature, which means I am having three different, what I can call, three analyzation variables. Maximum temperature, minimum temperature, I will say combination of maximum and minimum temperature. Here I used here the K-means cluster analysis. What is the purpose of K-means cluster analysis? I told you to cluster the data sets into groups. Nothing else. How, no, here what is data sets here? 36 data sets. Then again, so any clustering algorithm, what information you want, you require is some type of the indicators. Here we take an indicator called skill score. That means that any data matrix require some data sets, some criteria for evaluation. Here we've taken the criteria is mainly the skill score over the number of grid points. So the technique we did here is about the K-means cluster analysis, number one. And the three weather parameters you've taken is the temperature based. And to find out the optimum cluster size, we have taken here the Davis-Ball index and the F statistic. Like this, the number of validation techniques are available. So after doing it, what happened here? You can see here optimum clusters for T max, T minimum, and the other group is becoming 3, 2, 2. You can ask me what is meaning of that. The out of 36 models for maximum temperature, there are only 3 groups are happening. That means 36 divided into 3 groups. You can check out where is 36, where is 3. Is it right? That means that if everything goes logical, you need not worry about all 36 GCMs. You can worry about 3 representative GCMs for your analysis. Typically, you can take for the minimum temperature. Same thing, minimum temperature is still more funny. It becoming only 2 representative GCMs. That means very 36, very is 2. So you can see here, that means you can see in the case of the first cluster, that is about the maximum temperature, we found that after 36 GCMs, you have taken this one representative GCM, another representative GCM, and representative GCM. In the case of T minimum, representative first cluster, representative second cluster. See how much quality time you are going to get now. 36 GCMs, analyzing, keeping your time, stretching your time, trying to understand, do a lot of complex mathematics. That is one way of doing it. Second way of doing it, simplify the process and try to understand the best possible what is happening, how we can use this for further purpose. But somebody can ask me, sir, if you are doing clustering analysis, are you going to do some information? Definitely yes. But that is balanced by what? The time I am trying to spend with more number of data sets. It is one type of what I can call a trade-off impact. One is the time, other is what? The accuracy. So I prefer to go with the time because I'm not worried about the accuracy, because even though you lose information, you will not do such information that you have to worry about it. You will not worry. So this is the purpose of clustering the GCMs. Then that's why whatever I told you, same thing I want. So this is wonderful graphs which we created, part of a research paper. You can see this. So we have taken, we tried with the clusters 2, 3, 4 like this. Then you can see what is error. I told you, as your number of clusters are increasing, it is expected that your error will decrease. What is error? Data sets into the corresponding grouping. You can see here. So as your clusters are increasing, your error is going to be decreased. At some point of time, one of the observation is that all 3 variables are reacting in a similar way. Similar way means what? Reacting parallelly. Typically, this is nothing but what? The Davis-Ball index. Davis-Ball. What is Davis-Ball index purpose here? To find out optimum cluster size. Then this is in terms of another validation index called F statistics. So that means that most of your skill depends on option number 1. Graph looks interesting, that anybody can say. What your skill lies is that why This graph is behaving like this. How this graph is trending like this. What is the reason of intersection of these points at some point of why this convergence is happening, etc, a long list you should see, because most of our maybe young faculty member, maybe young research scholar, maybe of my age also, but try to take always the problem in a very critical way. That is the way your skill should lie. Then other point about that, again you can see here. Now when, for example, I have taken, there are number of clusters 2. So you can see out of there are out of 36 data sets, 32 become one cluster, 4 becoming another cluster. That means out of 30 which is representing here GFDL, ESM, 2M, another 4 GSSS, E to H. This is for the if you thought it 2 clusters. With 3 clusters classification, you can see here 25 GCMs in one cluster, 10 in another cluster, 1 is another cluster. This is called singleton. That means it maintains its own identity. And most probably it will continue as the number of clusters are even increasing also. If you take the 4 clusters, you can see here, that means as the number of clusters are increasing, what is going to happen? The data sets in each cluster will come down, because naturally, initially, you told 1 room, 2 people can sit. Now you say 3 people can sit. Naturally, people try to make more groups now. More in each group, number of data sets also may come down. You can see here, that means 7 clusters, 8 clusters like that. As I told you, HCM3 will maintain a single individual position at every cluster. This is for the maximum temperature. Same thing with respect to what? The minimum temperature. Minimum temperature. You can see here in the maximum temperature, what are the clusters here? The GFDL ESM 2M, GSE 2H. Again, you can see this is different. What I'm trying to convey, you require a lot of patience by analyzing the data sets, because anybody can see this 35 and 1, but you should go back to one step and you should say, why this 35? What prompted that this is 35 falling one cluster? What prompted to take into one in another data set? Like this, you can take it in the similar. This is nothing but what? The combination effect. Combination means what? In terms of a combined maximum temperature and minimum temperature. So you can see here, interestingly, in the first case, GFDL is falling 32 data sets. This is 35. This is 35. But you can see the reference data sets are changing. Here we try to analyze the problem with starting with 2 clusters, ending with 9 clusters. You can ask me, how you know, sir? That much logic we should have. Otherwise, you can, nowadays, once you develop the computer program, it is simple cakewalk to understand, to play the impact of each and everything on the outcome. That is not a big challenge. So that is about the climate change part. So typically, we try to do even other case study, the classification of the meteorological stations. What meteorological stations? Which measure what I can call a rainfall, temperature, relative humidity, etc. What your agenda? Agenda is to classify these meteorological stations into some particular groups. What purpose? Once classified, you can make any maintenance. That means instead of handling each data set independently, you prefer to handle the data sets in a particular group for the convenience purposes. So this is, we're taking these variables. My interest is to tell that here we try to use here the Kohanon, K-means, and the fuzzy C-means. All three algorithms. So that my interest is simple. As I told correctly, as number is increasing, error is expected to change. Here also we try to use here the Davis-Burdon index. So like this is simple mathematics. But only point in that K-means cluster analysis is that you are belong to one group. In the fuzzy cluster analysis, you are belonging to multiple groups, because due to the imprecise nature, flexibility. Otherwise, you can ask me, sir, why should I go for multiple clustering techniques? The first question, someone should ask me by this time. Because every clustering algorithm works with certain philosophy. It is always advisable, what I can call preferable, to understand how each technique is reacting to the same data set. Remember, same data set. Fuzzy cluster analysis, we behave differently. Cluster analysis behaving differently. You You can see here, we'll try to make it 14 groups. In one group, you can see fuzzy clusters having 12 data sets, 12 metrology stations, another 80. You can see 11 here, 1 here, 14 here, 2 here, same data sets. Algorithm changed. Algorithm not changed significantly because one case it K means, second is fuzzy C means. So typically, you can see here, cluster analysis 2. Is it right like this? So keeping all this in view, always try to see how each algorithm can respond to the given data set. Nothing else, nothing more. Similarly, you tried here the Kohanon neural network also. So this is a classification of the metrology stations, how we are using the different 14 clusters, how the metrology stations are classified. So my suggestion to all of you, you can think of how the problem can work out in best possible way. In summary, today I have taken up in 30 minutes module. I talked about briefly about the clustering algorithms on the K means, fuzzy C means, Kohanon, talked about validation techniques, talked about 2 case studies, one case study based on the clustering of global climatic models, second clustering of the metrology stations. In the first case study of the global climatic models, I have taken only K means and Davis-Bode index and F statistic. In the case of metrology stations, I have taken here Kohanon, fuzzy C means, K means, and Davis-Bode index. So this wonderful research area, and really anybody interested, they can pursue their research interest. Thank you all. Any discussion? Welcome.
Thank you very much, sir. Thank you very much, sir, for a nice presentation once again with our institute and department. We are on time, sir. If at all any questions, if I get, I will definitely mail you. Yeah. We are proceeding with the next slot as per schedule.
Thank you. Thank you for the Girish. Thank you all.
Thank you very much, sir. Happy Dasra to you and to your family.
Thank you all to all the participants. Yes. Thank you very much.
Yes, thank you, sir. Yeah, the student coordinators will proceed with the next session now.
Yes, sir.
Yeah,
yes, sir. Thank you, sir, for such a knowledgeable keynote, and it was an obvious expert talk. Once again, thank you, sir, for your time and consideration towards ScTACE 2021. Now, moving ahead with next keynote by our esteemed speaker, Professor KVL Subramanian, titled 3D Printing of Concrete with Low Energy Alkali Activated Binders for Effective Construction. Professor KVL Subramanian has obtained his BE in Civil Engineering from IIT Delhi in 1993, MS from University of Toledo University in 1995, and PhD from Northwestern University, Avastan, USA in 1999. He is the professor at the Department of Civil Engineering, Indian Institute of Technology, Hyderabad. Professor Subramanian was awarded numerous honors, Comprehensive of Teaching Experience Award in IIT Hyderabad for the years 2011 and 2016, the Outstanding Young Researcher Award, Kettle Research Fellow Award in 2006, Early Career Award from National Science Foundation in USA in 2003, ASCA Faculty Award from City College of New York in 2003, ACI James Instrument Award in 1999 for research in non-destructive testing of concrete, and Walter P. Murphy Fellowmanship from Northwestern University in 1996. He also fashioned the position of editorial board member of Cement and Concrete Composites, Associate Editor of Journal of Materials in Civil Engineering, Associate Editor of Journal of Bridge Engineering in 2009, as a guest editor of International Journal for Computational Methods in Engineering, Science and Mechanics in 2014. Professor Subramanian has 45 plus publications at international and national conferences, 90 plus publications in well-respected national and international journals, and authored a couple of book chapters as well. His areas of interest involve behavior of concrete and masonry structures, alkali activated binders and geopolymers, rheology control and 3D printing, fiber reinforced concrete, sensor development for concrete structures and infrastructure monitoring, low-cost housing solutions with prefabricated elements, and repair systems and strengthening of concrete. In addition, Professor Subramanian has been one of the editors of ScTACE 2021 conference proceedings. Thank you so much for all your support extended towards ScTACE 2021. And now I would like to hand over the session to Professor KVL Subramanian Garu.
Sir, good morning, sir. Welcome to this conference, sir.
Thank you, Prapala. Thank you indeed. Thank you for giving me this opportunity to present at this conference. I had chosen a topic which I thought is current. A lot of people are very enamored with this whole concept of 3D printing. It's become quite a buzzword. Also, of course, we're talking about these alkali activated binders or geopolymers as they're called. So I mixed them up. I basically brought them together and I made a topic which I thought is current and addresses two of the more recent challenges that we're facing with our construction in general. So let me start by sharing my screen. I know I have about half an hour. Let's hope. Yeah. So I hope my presentation is visible.
Yes, sir. Clear, sir. Can you make it?
I'll just go to the. Yeah, I'm just going there. Yeah. Okay. So yes. So good morning to everyone. Like I mentioned, I'll be talking about 3D printing of concrete. This is quite the buzzword now. We're all, in terms of construction technology, perhaps this is the most exciting thing that's happening in construction technology. And of course, these low energy alkali activated binders are these new binders that are coming into market, which are aimed at replacing cement that we use so extensively in making concrete. So the whole point, the challenge that we're facing in construction now is we want to build taller, we want to build faster. And one of the biggest challenge we have is with built shapes. The current shapes that we can build with concrete are limited with what we can form on site. So what we can form on site basically is rectilinear, which means it is rectangular or close to rectangular. Now we know that rectangular shapes are not the most efficient because we know that when you have a rectangle, let's say a rectangular beam, the material close to the neutral axis really does not give us much in terms of strength or resistance and shear. But we have that. We have that material riding along. And so more often than not, at least in concrete construction, because we're stuck with rectangular cross sections, these don't necessarily end up with efficient use of material. We use a lot of material, excessively more than what is required for structural purposes, which makes these structures heavy. So there are two things happening here. We are not anywhere near lean construction. We are not using material efficiently, and we are making our structures heavier than they have to be. So now, basically, where we can even where we have been moving away from rectangular shapes, we're still limited to I or T shapes. So these are limitations that we have. Now, what if the optimal shape was something like this? Suppose I do a structural optimization and I figure out this is the shape I have to make, or this is the optimal shape of a column. This is simply not possible with today's casting technology. I cannot make this on site. It is just not possible. So that means I have to invent a new method of forming, a new method of construction, which allows me to make these shapes, which allows me to make these complicated shapes, which are structurally optimized, and they may not necessarily be rectangular. The other issue with going faster is currently the rate limiting step in construction. Rate limiting is something that limits the speed with which we can go. Is the form of construction that we have. That is, we have formwork, we have to put the formwork in place, tie the reinforcement, then place concrete, then disassemble the formwork. So this formwork that you see here has to be disassembled, and then it has to be assembled again for the next floor. So the whole process is very labor intensive, and it slows down the entire construction. Therefore, we talk about things like slab cycles, and typical slab cycles are like, even at a very fast pace, are like 7-day slab cycles, which means that you cannot build one floor or one story of a building faster than 7 days. So if you have a 70-story building, then you are basically limited by going at a 7 or a 10-day slab cycle. That is the fastest at which you can build a structure. So these are limitations of the challenges in terms of trying to get into the digital age. So with that, now people started paying a lot of attention to construction and performance during placement. That is, we started looking at how can we improve this aspect aspect of construction. So a lot of effort in the last 1 decade has gone into transportation and placing of concrete. How can we transport concrete very efficiently? So transport means not just moving it, but also technology involving pumping. How can I pump concrete to a great height? Today, we have technology available which allows us to pump concrete to 800 meters or a 1 kilometer height, which allows us to go to super talls. That means I can be sitting on the ground, I can pump concrete to a kilometer in height and be building a structure there. So that technology we have mastered. Then we came to self-leveling, self-consolidating methods where we minimize the requirement of labor for concrete to fill the form. So you place the concrete, you forget about it. The concrete fills the form. It is self-leveling, self-consolidating. The final paradigm, of course, where we're moving to is this formless placement, where I don't require a form. And that truly liberates us, that truly frees us from the constraints of formwork. We can really speed up construction, we can go very fast, and we can build up all these shapes which are not possible with conventional formwork. So this is the whole point of 3D printing, and the most popular technique of 3D printing is extrusion-based 3D printing. What we do is we take a structure, we digitize it, and we basically develop a layer-wise idealization of the structure, and the structure is built by depositing one layer at a time, and the entire structure can be built up by depositing these layers. Now, this is what we are all excited about. This essentially started with this technology for contour crafting, which of course dates back to late 70s, early 80s. And now this has really caught on, where contour crafting has taken on new forms, where we're talking about extrusion-based 3D printing. And this we are basically betting as the technology of the future in terms of construction. But of course, for us to achieve this, to make this possible, I have to basically engineer the material. And that is where engineering the material itself is becoming very important. Now, if you look at the past, I would say 1970s, 80s, we were engineering concrete. We started making concrete by paying attention to the material science of the cement, material science in terms of packing. We started producing concretes which are very strong. So the performance objective we were after at that point was strength. And we started making concretes which are stronger and stronger over the years. And that was achieved by engineering. Now we are talking about engineering the fresh properties of concrete. Can I deliver concrete that will basically allow me to build a structure layer by layer? So for that, we need to understand what are the requirements of this concrete. Now, the requirements of concrete are simply illustrated with this very simple example for toothpaste. If you think about a toothpaste, when I squeeze the toothpaste, the paste comes out, and the minute I let go, the paste keeps its shape. The shape of the toothpaste that has been extruded, that has been pushed out of the tube, basically is the shape of the nozzle that it comes out of. And that's basically the kind of material I have to engineer. I want concrete that when I push it, when I pump it, it moves through the pumping system, it comes out of the nozzle, and it keeps its shape. And that is what I have to engineer the concrete to be. It has to deliver this flow performance. And it's a very complex issue. It's basically getting into the domain of rheology control. And this is something new that we're adding into our concrete technology, is to control the flow behavior. I want to control it. So concrete should be able to flow under pressure. It should have a fluid-like response. So this is gets us into the domain of rheology, where we have to understand what is the stress versus shear rate behavior, like a fluid. Then once I extrude it, it comes to rest. It has to quickly build up a structure inside so that it can keep its shape. Not just that, I should be able to add layers, because I have to build a structure layer by layer, which means I should be able to stack more layers on top of this layer. So the internal structure inside the material has to build up very quickly. And that's what we are now working on in terms of engineering the material. So now, just to understand what concrete is made up of, and what we expect in terms of the concrete. This concrete, if you look at it, is basically has aggregate, which is held in a suspension of a binder paste. The binder paste could be cement paste, or in our case, we are talking about this alkali activated material paste. So you have aggregate, which are held in a suspension of this paste. Now, this itself is a very complex suspension. It has several solids present in it. When I pressurize it, when I pump it, when I push it through a tube, it has to flow. It has to be homogeneous. That means the aggregate, all the binder paste, everything should flow like a unit. I cannot have the aggregate separating out. The entire thing should flow without any phase separation. That means it has to flow like one unit. Then once it comes out, that means once I remove the pressure, once it has come out of the nozzle, it in the at rest state, that means now it is sitting at rest, the an internal structure has to be created inside the material so that it keeps its shape. Now, not just that, once I finish depositing one layer, when I start depositing the second layer, the first layer should be strong enough, should have internal structure that it should be able to take the weight of additional layers. And we call that structure buildup. There has to be a buildup that has to take place. It's not setting or strength gain, it is buildup. The material itself still is in a fluid state. That means it is still not set, but it has enough internal resistance structure that I can keep adding layers. So that's what we are looking to engineer in this material. And to engineer the material, we have to basically look at this binder phase rheology. We have to understand what the paste behaves like and what happens when we add aggregate to it. So just to quickly introduce what I mean by saying alkali activated binders. There is a lot of excitement about these alkali activated binders where we produce cement-like materials by activating fly ash and slag. So we basically add some alkaline activated to fly ash and also some silicates into the solution. And what we get once it hardens are these cross-linked chains, which are called sodium aluminosilicate hydrate chains, and they're broadly called geopolymers. And these are totally cement-free binders. So basically starting from pure fly ash, using sodium silicate and sodium hydroxide, we're able to produce these binders, which are in a lot of sense stronger than cement, more durable than cement. So we are producing these materials which are made totally from waste materials, which give us good performance. Now, the thing is to use them in making concrete. And of course, make that concrete printable. That is the whole exercise. Now, of course, we can also activate slag. Slag is another waste material which comes from refinement of steel or during production of steel. And we use an alkaline activator with slag, which consists of sodium hydroxide and sodium silicate. And what we get is a product called calcium aluminosilicate hydrate. And again, this is a totally cement-free binder, which has good strength and is being used to replace cement. What we are working on as a blends of fly ash and slag to overcome the limitations of both. I'll show the limitations of what these binders have. So we blend fly ash and slag. Remember, both are waste materials. We alkali activate them, and what we're able to get is a binder which basically sets at room temperature, gives us strength, and it's a highly workable mix. So now, when we have fly ash and slag and we subject it to alkaline dissolution, the chemistry, the chemistry becomes quite complex, and we've understood this. We are now understand that when I blend fly ash and slag, I alkali activate it, I get a product called calcium aluminosilicate hydrate in the system, which resembles what cement produces when cement undergoes hydration. So we've also done a lot of work on the stoichiometry to understand what kind of products are being formed when you take fly ash and slag and you activate it using sodium hydroxide and sodium silicate. So now coming back to this form-free construction. So I've given you a glimpse of what is required from this form-free construction. I've talked about the binder that we're planning to use to make our concrete. But what exactly is this form-free construction? So this is a schematic that explains how this works. We take a mix of, let's say, something like the concrete. We put it into this hopper here. It's a pump which basically pumps the concrete, goes through this pump, and then this is a robotic arm that basically deposits concrete in layers in the place that we want. So this concrete has to endure this pressure. It has to go through this pipe here. Then it has to come out with the nozzle. It has to keep the shape of the nozzle. And as I keep adding layers, it has to take the layers which have already been deposited, have to take the weight of the additional layers. So broadly, what is required? We need pumpability. We need non-segregated flow. The concrete should flow like one material inside this pipe. It should keep its shape after coming out, and it should allow buildability. So now these have become new terminology which have been added to our lexicon, is understanding the pumpability, the non-segregated flow, shape retention, and buildability. So we've basically started working on this. And of course, this requires understanding the material at its behavior. So if you now look at extrusion-based printing, the first requirement is pumpability. If I pressure the liquid, and this is suspension, I have aggregate with the binder paste. When I pressurize it, I should not have any phase separation. So I should not have water and other lighter materials getting squeezed out. Then it should have printability and shape retention. So as it's coming out of the nozzle, it should keep its shape, and buildability. So you see what happens when I don't have buildability. As I stack layers, I can have collapse. Whereas when I have a good buildable mix, this is what I get. I can stack layers and basically build the structure up one layer at a time. So this gets into rheology control. We need to understand what is rheology, and we basically have to understand what fluids are, because now this is taking us out of solid domain. We need to understand what is the fluid behavior, what happens when you apply shear to a liquid. Now, whenever we have a viscous liquid or a thick liquid, we measure flow in terms of slump. That's what we do. We fill a container, we lift the container, and we measure how much the material has slumped. Now, we can, of course, get either a flow or a slump kind of a behavior. Now, this depends upon how material behaves under shear. So this is understanding what it takes to initiate flow and what it takes to sustain the flow in this mixture. So now we are beginning to understand that these materials are very complex in their nature. When I have a material at rest, and suppose I start shearing it, so I'm basically shearing this liquid. Initially, the particles of this material are going to be in a randomly distributed state. When I start shearing it, these particles tend to cluster up, and they start offering more and more resistance to shear. So if I measure the shear resistance of the material, the shear resistance actually increases when I start applying shear. And then eventually what happens is that the network ruptures, and all the particles get aligned and they start flowing. So the material has initially some resistance. It doesn't flow if you just apply some shear stress. That's what we are discovering, that these materials have that property. That is, if it is sitting at rest, it takes some effort to initiate that flow. And that effort to initiate flow is called yield stress. It is different from the yield stress we measure for steels and other materials. This is the yield stress of a fluid suspension. It is the effort that it takes to initiate flow in these suspensions. And that has to do with the way that these particles inside the material are aligned. Initially, they densify, they form a dense network of an increased resistance to flow. Now, once the material starts flowing, we understand that it offers resistance to flow in the form of viscosity. So viscosity is a measure of the effort that is required to sustain the flow. Now, I want to lower the viscosity as much as possible, because once I initiate the flow, I don't want to put in too much effort to keep the flow going. The final thing that we need to understand is thixotropy. Thixotropy is another property where once I suppose induce flow, so I've sheared the material, initially the material has densified, then with application of shear, the network ruptures and I get all these aligned particles. So the material is flowing. But after I remove the shear stress, suppose I put it at rest. So now this is simulating the condition where I've sheared the material, I pumped the material. And when you're pumping the material, the fluid is under a lot of shear stress. I pumped it, I've sheared it, and then I put it at rest. That means I've now brought it to rest. And in the at rest condition, what happens is that again, the structure starts building up inside. So you see, when the material was flowing, all the particles were nicely aligned. Then when it comes to rest again, the particles become randomly oriented. So when the particles become randomly oriented, again, you'll have resistance to flow. That means internal structure starts building up, and now the material will tend to keep its shape because it takes some effort to overcome this structure. So this is, and with time, if I wait, the structure again densifies and the resistance to flow starts increasing. And that resistance to flow post-shearing response is what we call thixotropy. So basically, when we're talking about this geopolymeric blends, when we mix fly ash and slag, we find that if I use only fly ash, it has very low thixotropy. That means it doesn't build up its structure after shearing. It is very viscous and it has a very low yield stress. That means the effort required to initiate flow is very small, which means if I place this material, it will slowly lose its shape, and that is not desirable. Whereas when I only activate slag, I get a very high structural buildup, which is desirable. It has a high yield stress, which is desirable because then it will keep its shape after when it's at rest. But it's very fast setting. It starts setting too fast, and then I have problem of the material setting in the nozzle itself or while I'm pumping it. So therefore, we blend these two materials and create an optimal material, which basically gives us best of both the worlds. That's what we get when we blend fly ash and slag. Now, this is what we have to basically engineer. So if I take a normal concrete mixture and if I dump it into water, what will happen is that all the constituents will simply separate out. That's typically what will happen. Now, how do I keep the integrity of this material? I have to basically give it some cohesiveness that keeps these particles together. So I have to increase the cohesiveness of the mix while allowing high flow, what you see here. So it is flowing very easily, but even after going into the water, it is still cohesive. It's not getting disrupted. It is keeping all its particles in suspension. And that is basically this whole thing of rheology control. So this is now what we are aiming to do. When the material is at rest, there is a structure that exists inside the concrete. And this structure basically consists of a network that is formed, which can resist shear. When I apply shear, the structure is disrupted. All the particles get aligned. And so I get a free flow which allows me with pumpability and easy pumping. And then when I bring it to rest again, the structure develops inside, which is able to resist the applied shear stress. That means it keeps its shape. So this is what we're working on with rheology control. And of course, there's a lot of work that is being happening to understand what is the state of this fluid inside a printer, where is the high shear stress, what is the magnitude of shear stress, and then trying to engineer this binder paste and the aggregates by packing to achieve this desired final product, which allows me to deposit layer by layer and build the entire structure. So with this rheology control, we are able to now, by engineering the thixotropy, the viscosity and the yield stress, which is achieved by using some admixtures like water reducers. We use nano and microfines, which allow us to control the viscosity and also the thixotropy. We use retarders to control the set time, and we use clays. And now we're starting to use a lot of nano clays and clays in these mixtures, which give us the thixotropy that is needed for achieving buildability. And you see, we can build an entire structure layer by layer. That's what we have managed to do. And we have managed to develop a printable alkali activated fly ash slag mixes. I'll just show you a structure. This is a wall that was printed. This is the cross section. It's like basically a rectangular cross section. We are able to print heights of about 2 meters with this material. So this is, in a nutshell, by engineering the material, we are able to deliver a material that allows us to deliver a form-free printing or form-free production. Now, of course, I should not sound like everything is positive. We have engineered the material for rheology so that by adjusting the mixture composition in terms of particle packing and through rheology control of the binder, and we are heading towards lean construction. Now I can print shapes which are not rectangular. I can start printing shapes which are more complex and lead to a more efficient use of material, which basically gets into lean construction. But of course, there are limitations. The limitations I have is that I'm limited to printing micro concrete right now. Right now, we're not able to print concrete with large aggregate. We are limited to printing with aggregate which are less than 4 millimeters. And we are right now integrating reinforcement into this concrete while we are printing is still a challenge. So these are things that we're working on right now, is to basically start printing with regular concretes, with normal sized aggregates, and to somehow integrate reinforcement into this printed structures. Now, just a final thing that now, in addition to printing, we are also starting to work on embedded sensors. These are sensors that you can put in concrete. And once you put them into concrete, they basically can help us understand whether the printed structure that is developing strength adequately, whether it is developing properties adequately, whether it is keeping its shape adequately. And these are sensors which are made using PZTs or piezoelectric materials. And the whole concept in the end is to basically be able to print a complex structure with these embedded sensors inside, which tell us about the health of the structure. So we get inline sensing for digital monitoring. So while we are printing, we have an inline sensor that is telling us how the printing operation is going, whether the material is developing strength adequately, whether it is delivering the performance adequately. And that sensor is embedded in the structure. It's embedded in the concrete, and it keeps reporting on the health of the structure throughout its life. So this is the whole concept of having the structures which are printed. Of course, you see here nice fine structure that's been printed. A small, of course, a very small structure with great level of detail. But think now that if you have a sensor that is sitting in there and reporting about the material deposition, the quality of the deposition, the quality at which it is printed, and report on the health of this structure throughout its life. So that's the other dimension that we are currently working on to make this dream of digital manufacturing of structures possible. So with that, I would like to thank you for your attention. I think I've used up all my time. So I leave it up to you to open the floor for questions.
Thank you very much, sir. Yeah, thank you very much, sir. It's a great information that we got with this 3D printing, and I request the participants to have a kind of discussion. Still, we have 10 more minutes. We'll utilize this opportunity and get the fruitful results.
Good morning, sir.
Good morning.
Happy Dasra, sir. I am Sri Krishna of 3rd Civil, sir. So thank you very much for your talk, sir. I have a small question, sir. Can you please suggest us the best 3D modeling software, sir?
Okay. Yeah, I'm a little surprised to this question because when we are developing technology, software should not necessarily come before the technology itself. So this is a technology, particularly dealing with 3D printing, is still very nascent. So just to give you a little background, you see, the whole concept of 3D printing is not new. It is about 2 decades old. The mechanical engineers have been using this technology for printing a lot of with polymers and metals. What we are doing is extending that technology to use it for civil engineering structures. So we are borrowing a lot of their technology in terms of the robotic control, etc. And there's no point reinventing the wheel here. So if you're talking about the control of the robots and the robotic arm control and all of that, then a lot of that is available. A lot of it is open source. It's called a G-code programming. You can actually go download it. You have Arduino control boards which are available. You can buy them. They're readily available. And you don't have to put a lot of effort into that part of it because it's been developed. So we are basically trying to use the same technology. See, as a civil engineer, I really don't want to spend time and effort in trying to control a robot arm into moving a specific distance at a specific time. That's all been done. I want to use that to deposit material, especially concrete, and build a structure out of it. So what we are all working on is engineering the material itself. How do I now make this concrete, which we all know flows? We've all done slump test. The minute you remove the slump cone, the concrete collapses. Now, the thing is, I want to take this concrete that when I pressure it, when I pump it, it flows. Right?
Yes, sir.
At the same time, when it comes to rest, it keeps its shape. So this is like 2 conflicting requirements, is where it has to flow, it comes to rest and keeps its shape. So that's a challenging topic in material design. And as civil engineers, I think now we're starting to pay attention to it. The chemical engineers have been doing rheology control for a long time. In fact, I should tell you that the toothpaste that we buy, a lot of rheology goes into it. There are top-class rheologists who work on making sure the toothpaste has the required consistency. When you squeeze it, it comes out, it keeps its shape. That is not an accident. It's done with proper rheology control. We are simply bringing that into concrete, making sure we achieve it. So having said that now, the software part of it, the 3D part, the 3D digitization part of it is the first part. That is readily available, where you can take a structure, you digitize it into layers, and then you feed it as input to the robotic arm control. And the robotic arm control, the movement of the robotic arm, deposition, and all that is also available. Broadly, if you look up mechatronics is the field in which a lot of this development happened. So all of that is available. Coming to the software for the mix design, we don't have yet. We're still in the development stage. We're still working on how to develop these mixes. So that part of it is still ongoing research. It's active research area. Softwares are still not currently available for the material design part of it. The digitization and the deposition, the robot arm control and all that software is available.
Yes, sir. Thank you, sir.
Sure.
Good morning, sir. I'm Saranya from 3rd Civil, sir.
Sure.
Sir, how much money does we initially need to be invested in order to build a single store 3D modeling construct?
So single story structure.
Sir, Yes, sir.
Yeah, that I think the printer technology for concrete is still being developed. I would say there are some good startups. In fact, there are some startups which are started by young BTech students at a few places. IIT Madras, there is one startup. There are a few other startups too. They have come together. They brought together people from electrical engineering, mechanical engineering, of course, civil engineering, and now they're starting to make these printers. And they have developed this technology because what conventionally mechanical engineers do is print something in a small scale. The mechanical parts, components are small, but you have to scale it up because we're talking about a structure. One story is 3 meters in height, probably a little more. So we should be able to print, and our sizes are in meters, not in centimeters. So you have to take that technology and scale it up. So if they're talking about a pump of a certain size, we're talking about the same pump multiplied by 100, because now the volume of material it has to handle is very high, and our material is also very tricky material. It is very viscous material. It takes a lot of power to pump it. So that is where the engineering is taking place. And so in terms of money, you can probably, if you look to buy a commercial printer today of which would probably print concrete, I would say you could probably buy a printer, a small scale printer, which will do a printing of the size of a few meters, not more than that. Will probably cost you anywhere from 30 to 50 lakhs. You can invest that kind of money and get it. But you could also develop your own printer. If you, a few of you can come together and engineer, it will be much cheaper. So if you can get together some expertise from mechanical engineers who have the expertise in G-code programming and robotic arm control, you can actually build a printer.
Okay, sir. Thank you, sir.
Sure.
Sir?
Yeah.
Good morning, sir. And this is Abhirami, sir. And firstly, I would say that your session is very knowledgeable and you have shared great insights on 3D printing, sir. So my question is that 3D printing is generally like related much for structures. So how can we draw a relation between 3D printing and can we get that into urban transportation sector as well, sir?
Yes. In fact, I had a few slides. I removed them, but I should probably have kept them. That would have given you a little bit of perspective. Now, I'm not sure if you're aware that there are machines, I won't call them printers, that actually extrude concrete pavement. So basically, this is an automatic paving machine. You put concrete into a hopper, and on the backside of it, it basically starts laying a pavement. It doesn't require any formwork. Basically, the entire pavement gets extruded and it gets deposited on top of the subgrade. So these were actually attempts of similar to 3D printing. You're basically extruding, of course, only one layer. And what they do is they produce this zero slump concrete, and they produce this pavement. So the entire operation of casting a pavement becomes so much faster because you can simply extrude it. The machine moves at I think if I'm not wrong, I think at the pace of about 1 meter every 10 minutes or so. So you can start making a pavement which is 1 meter in length in about half an hour. So you can simply start extruding this and make an entire pavement. So this is printing technology that's finding its way into transportation in terms of pavements. Then printing technology eventually will, of course, find its way into printing of structural elements. So those will go into bridges. So if I can 3D print elements which can be used in bridges. Now, one of the things I mentioned in the beginning of my talk was to say that we are using rectangular beams and rectangular columns. Now, a rectangular column or a rectangular beam may not be the optimal shape. The reason we use it is because that's how we think of concrete. We think of a formwork which is rectangular. We place concrete inside the formwork, so we are stuck with a rectangular form. But now more and more people are starting to look at topology optimization, and they found out that I can get the most efficient use of material, which is structurally the same as a rectangular beam or assembly, with other complex shapes. And there are groups in Europe that have already 3D printed bridges using this topology optimization. And those do not have your rectangular cross sections. They're printed. So I'm hoping that technology catches on so that we'll be able to now deliver that for in bridges as well. So we start getting bridges which have optimal use of material, which give us the same structural performance as you get with your conventional rectangular beam column systems.
Yes, sir. Thank you, sir. And adding to that, one more extension I have, sir. Like
Sure.
3D printing has been a low costing element nowadays. So what about the texture we can expect from 3D printing, sir? Like conventional methods, we can have a good texture also, good appearance. And what about 3D printing texture, sir?
Yeah, I mean, at this point of time, I don't think people have paid much attention to texture. The reason is right now the technology is in a nascent stage. We want to make sure that we can deliver a structure first. So, but I'm sure with time, even texture will, people will work on texture and make that also a reality, that we get concrete structures which have the desired texture that you want. I think that will come find its way. But yes, at this point of time, we are not too worried about the texture because we want to deliver something that can be used in structural use.
Yes, sir. Thank you, sir. And not to waste your time, one last doubt, sir. So generally we use recycled materials also while we are paving or while we are constructing structures. So is there any limitation that we shouldn't use such materials in 3D printing, sir? Any limitations for that?
As of now, there are no limitations per se. We just have to understand what that material would do if you put it into your conventional blend and compensate for it. If it somehow adversely affects the property, then we have to compensate for it. If you look at recycled aggregate, like these aggregates are finding their way into concrete and subgrades in transportation structures. We know that those aggregates are weaker and they do tend to affect the strength of concrete. But we have now managed to make concretes of good strength using recycled aggregate by basically understanding what causes the weakness. So we have to adopt a similar strategy when it comes to use of recycled materials, that when we use these, they will have some adverse effect. We will have to overcome it, and eventually we should be able to use them in printing as well.
Yes, sir. Thank you, sir. Thank you for patiently clearing all the queries, sir. Such a wonderful session. Thank you, sir.
Sure. Thank you.
Thank you so much, sir, for such an immensely valuable talk, and we are grateful to you, sir, for all the assistance and support you have bestowed towards ScTACE 2021. And now it's time for a short break, and eventually we will gather at 1:30 p.m. for the presentations of Day 2 of ScTACE 2021. I request the authors and listeners to kindly join the respective panels at least 5 minutes before the start of the panel session, and it is mandatory for the presenters to turn on their videos while presenting their work. The joining links for respective panels are mailed to you all, and I wish you good luck with the presentations.
So thank
We
you
are
very much, sir,
expecting
for your time.
Thank you.
we are
Thank
expecting everyone We are expecting every one of you to join the session for the keynote and guest talk by influential speakers from abroad. You can join the session at 6 p.m. IST using the same link as as that of morning, and you don't miss the significant talks. Thank you.
Sir, I would have a word with you, sir, if you allow me. Very recently,
Sure.
we have our IIT director visit to our campus in the
Uh-huh.
last month. And also he suggested us to meet the Department of Civil Engineering at IIT Hyderabad and try to collaborate. I mean, for our students to get more benefited with the research or something. So I request if you could spend some little time with our students once, maybe coming week or sometime. Maybe for a small interaction with my students, and maybe they'll get some good ideas for doing research, because our students are doing good research, undergraduate students, final year and third year. Also, we are trying to publish research papers, and also we have received good number of citations for students articles also. So to encourage them, we really need and I know support from your end also. So I request you
Okay.
to please.
Sure,
Thank you,
sure,
sir.
no problem. Yeah,
Thank you for
no problem.
accepting our invitation and also being one of the editor. And we had very good responses from the authors also. Thank you very much, sir.
I saw that. Yes. Okay. Sure. So thank you. Let me know if you need any help with the editing and other things. I hope you have all the papers in place. So,
Yes.
but if you need any editorial assistance, I'll be happy to help you with that. I know I've not been very attentive to all the other requests, but yes, please do let me know.
Sure, sir. Sure, sir. Thank you, sir.
Right?
We'll meet you soon, sir. Yeah. Thank you.
Sure, sure. Okay. Thank you.
Happy Dasara, sir. Have a nice day.
Happy Dasara to everyone. Thank you. Bye.
Bye, sir. Yeah, that's all. We can close this. We can end this session, and maybe we can join for the panel and followed by in the evening sessions. Thank you once again. We'll see you soon in the noon sessions and evening sessions.